Hello everyone, I'm Makito. I'm the last presenter today, but you guys should not go away because there will be lucky draw after my presentation. Okay, so the topic I will talk today is the side-to-side layer 2 VPN with PPP BCP. Actually, I am the third person who talks about VPN today, thanks to the previous two presentations this morning and this afternoon about the VPN. So I think most of you have already known about the basic configuration of the VPN. All right, before I start, I would like to do some self-introduction about myself. I am originally from Cambodia, which is the country next to Thailand. Myanmar, Thailand, Cambodia. And I am MikroTik certified trainer and consultant. Currently, I'm working in Myanmar. Specifically, I'm working in iBeam company as CTO, also the MikroTik trainer in iBeam. And my experiences are 12 years in ISP industry since 2005 and building solutions for ISP. Also, ISP core network design and operations. Currently, I am involved in setting up a few ISPs in Myanmar. For certifications, I have all the MikroTik certificates, plus CCIE and Juniper and VMware certificate. Because in the past 12 years, I was working in the ISP, so mainly my areas of interest is ISP. That's why the technologies that I am interested in are BGP, MPLS, and IPv6. All right, so now let's go into our topic. Today, the agenda, we will talk about 4 points. What is VPN and why we use VPN? And what are the VPN types? And I will have a sample topology. I will have the sample topology and I will talk about the configuration if you want to do that topology layer 2 VPN for side-to-side. Side-to-side means from office to office. Okay, first, what is VPN? VPN stands for Virtual Private Network. It is a cost-effective technology that can allow you to connect from one location to another location. Specifically, this one, the word location, it doesn't mean that you have to connect from company to company. It can be from your home PC to your company or from your company back to your home network. All are possible. And the purpose of connecting is mainly for sharing the resource on the network. Specifically, it is file sharing or maybe remote access to company intranet or ERP system. ERP stands for Enterprise Resource Planning, because in some companies, they have the internal system. For example, in the ISPs, normally they have the billing system for charging the money from customer and for doing accounting. For example, like in Ooredoo or Telenor, they have the billing system, how much you use, how much you call. So sometimes maybe there are staff which works or stay remotely, they need to access the system, then they might need to use VPN because normally such kind of system is not public on internet. Also, some offices, they might want to provide the secure access with authentication and encryption to the user. They want the centralized internet access. For example, all the users at the branch offices, when they want to access the internet, they need to go through the head office. So in that case, the head office can do the filtering, or maybe in the head office, they have some sort of log server, so they can know which user is using what services. Before we have VPN, actually, traditionally, if you want to connect from one office to another office, you need to run the list line for connecting to the remote location. But depends on the geographical distance, sometimes some connections might not be available. For example, you have one office in Yangon, and maybe you have another office in Shan State. So the distance is so far away from each other. Then in this case, it might not be very practical for you to rent a cable. Even if you can get it, maybe it is very expensive. Yeah, I used to get the quotation from MPT, something like 10,000 USD. So I don't think most of the customers, they can consider this kind of solution. With the latest technologies, some ISPs, they also offer something like Mpls Vpn, which some ISPs call Metro Ethernet. This one is good, and it is simple for customer. Because from customer point of view, I just plug in the cable, then everything works. So it is good. But from the ISP point of view, ISP, they need to do a lot of configuration. That's why most of the time it is not very cheap. And also because when you use Mpls VPN from one ISP to connect all your locations, if you are not happy with them, you want to change to another ISP, most of the time you need to change all the connections. Sometimes you might not be able to find another ISP that can cover all the locations. For example, you are using with MPT with 200 locations, and you are not happy with their customer service. You want to change to someone. I need to declare here, MPT just example. It is not I am saying they are not good. They're gonna kill me. All right. In case you want to change from one ISP to another ISP, then maybe the second ISP will say, some places we don't have the connection, but maybe they might have some other partners that can work with them to provide the connection to you. But in that case, the cost will be high because it is not their own cable. There are many these kind of cases in Cambodia also. Sometimes some regions, ISP 1 cannot cover, then they get the cable from ISP 2, and then on the surface they are selling to you as ISP 1, but actually it is the cable of ISP 2. So in this case, they have to mark up the price. It is not possible they sell cheaper than what they bought, right? Also, in case if there are some situations like what I mentioned at the moment, one ISP need to get connection from another ISP to support you, you will have poor interrupt. It means that from one ISP to another ISP, maybe their standard operation procedures might not be the same, or maybe they don't share the monitoring system. So sometimes when the fault happens in the network, they might need to escalate back and forward, and then you, as the customer, you will suffer the long downtime. So that's why we use VPN. VPN, if we want to categorize it by the Vpn Access Method, there are two types, which are the Remote Access VPN or Site-to-Site VPN. Remote Access VPN, it is for individual employee to access the company resource from home or remote location. Specifically, the client is your PC, and then the server is in your office. For site-to-site VPN, it is for company to connect to the branch office or connect to your partner office. So it is from one network to another network. It is not PC to the server. In this case, normally, if we use the hub and spoke topology, I will explain what is hub and spoke in the next slide. If we use hub and spoke topology, then the central VPN server, it is the hub router, and then the other locations VPN router, it is the spoke router. Okay, in this presentation, because we will focus on site-to-site, so I will not go to remote access. I will not talk about PC go to server. I will talk about from one location to another location. For site-to-site VPN types, there are two types if you want to differentiate them by the OSI. It is layer 2 VPN and layer 3 VPN. Specifically here, layer 2 VPN, all the VPN sites will share the same LAN IP subnet. Layer 3 VPN, each VPN site has different LAN IP subnet. So like this morning, there was one presentation, EOIP, that one, I believe it is, if it is using bridging, it is layer 2 VPN. If it is using routing, I mean, if you need to add static route, then it is layer 3 VPN. And for layer 2 VPN, the features are broadcast domain is end-to-end everywhere. and you have centralized DHCP server most of the time. You have centralized internet gateway most of the time. For layer 3 VPN, normally broadcast is not possible between the sides. So it means if you have the application that require the same subnet, or you have the application that require broadcast, so in this case, layer 3 VPN might not be okay for your application. But layer 3 VPN has the flexibility of independent DHCP server in each location, so you don't really need to have a centralized DHCP server in head office because you have different subnet. So you can have different policy, different DHCP server in each location. And it is possible to have individual internet gateway in each location. You don't really need to go to head office to go to internet. In terms of configuration, layer 2 VPN, it is based on bridging, no routing required. That's why at the moment I said for EOIP that someone present this morning, if he is using bridging, then it is layer 2. If he is using routing, then it is layer 3. Because layer 3, you are using multiple subnets, so you need to do routing between the subnets. Routing can be static route or dynamic routing protocol, RAID, OSPF, or if you want, you can use BGP. So this is the difference between layer 2 and layer 3. But in this presentation, we will mainly focus on layer 2 VPN. And by the way, here what I always talk site, it means location or office. This is the technical term in the VPN. Normally we say site to site, it means office to office, or specifically maybe head office to branch office, or branch office to another branch office. This is site. Common VPN topologies. There are two common topologies, hub and spoke or mesh topology. You can see hub and spoke, we have a central hub. Normally it is the head office. And you have multiple branches here connect to the hub. Normally each branch will have only one connection, which is going to the hub. The branch will not have connection to other branch. So you can say all the access, it is based on the hub. Even you want to send the traffic between branch 1 to branch 2, it is also through the hub. Normally, you will choose this topology if you want to do the filtering at the head office. Another topology is mesh. Mesh can be full mesh or partial mesh. If you have a lot of budget, then you can do full mesh. Because full mesh is each location has the VPN tunnel to all the other locations. For partial mesh, you will only connect to the main locations. For the unimportant location, you will not have the connection. So it is partial mesh. Okay, let's compare what are the differences in terms of technical. Hub and spoke. Normally, you will have one or more hub router, and it is usually located at headquarters or head office. And every spoke router establishes only one tunnel. So totally, the number of VPN tunnel will be the number of hub multiply the number of spoke. Simply means if you have 100 offices, you have one head office and 99 branch offices, so it will be 1 multiply 99, then it will be 99 tunnels. So totally only 99 tunnels. If you have 2 routers at head office, then it will be 198 tunnels. Just multiply like this. It is easy to deploy because very few tunnels. Every office only 1 or 2 tunnel, but it is single point of failure at head office. You can imagine if your head office drop the connection, or maybe the router down, or maybe fire happen. So in that case, the branch office cannot connect to any other branch office. Due to it has only one connection from branch to the headquarters, so it has the low risk on the bridging loop. Some of you might already know what is bridging loop. Bridging loop simply means when you have one switch connect to another switch with more than one connection, then the loop will happen. Loop means the packet just Go from one switch to another switch, back and then go again, back and go again. This one, it is loop. It will bring down your network if it happens loop. For the full and partial mesh, here every router is at the same level, so there is no hub, there is no spoke, everyone is peer-to-peer because everyone will have connection to everyone. But the problem is if you are doing full mesh, you're gonna set up a lot of tunnels. For example, the same example, you have 100 offices. If you do full mesh, you need to have this amount of tunnel. N is the number of routers. So you can multiply it, 100 multiplied 99 divided by 2 equal to how much? Let's go to the calculator. I'm sorry because I left school so many years already. 100 multiplied 99 divided by 2. Okay, so you will have 4,950 tunnels. You need to spend a lot of efforts to set up the tunnels. Even you do the partial mesh also depends on how many locations you're gonna do mesh, and then you need to multiply by that amount of routers. So it is very, very, very heavy task on deployment and maintenance. Don't forget, network is not only deployment. It is not you set up the box and then it works for 10 years. It is not like that. Sometimes you need to monitor. So as the network admin, is it easier to monitor 99 tunnels or is it easier to monitor 4,950? I think you got the answer. But it has good redundancy because it does not rely on the headquarters. So even you happen fire in your head office, at least your branch offices still can messaging each other, hey, our head office is fire now. And also because every location has more than one connection to other locations, so it has high risk on breaching loop. So normally we should use spanning tree for loop avoidance. Okay, so at the moment I talked about what is remote access, what is side-to-side, what is layer 2, what is layer 3 side-to-side VPN, and then what is hub and spoke, what is full mesh. Next, we have a sample diagram here. We will talk about the configuration, how to do this configuration. First, I need to say, due to the popularity in the real world and ease of implementation, in this presentation, I will talk only layer 2 side-to-side VPN with hub and spoke topology. Because most of the time in real world, many companies, they prefer to use layer 2 VPN over layer 3 VPN. Simply because layer 3 VPN needs routing. Not many people familiar with routing. And layer 2 VPN, normally they will use hub and spoke topology. As I said, full mesh is good if you have 10 offices, but if you have hundreds, then it is a nightmare for you. And for simplicity, I will not set up 100 offices like what I said at the moment. I will only set up one head office and 2 branches to show you the configuration. Specifically here in this configuration, in this diagram, you can see we have internet connection. So every office, we have internet connection. Sure, we need to do VPN over internet. And this is the IP address that you have. You don't really need to remember it. It is just a dummy IP. You can consider it is just your public IP. And at head office, we have PC 192.168.1.254. At branch office, we will have PC 1.1 and 1.2. The purpose of this VPN is we need to set up the VPN to let the branch office and head office can communicate with each other. Specifically, we will test by ping, normally. All right, so let's see what methods we can use. In RouterOS, first you might think about EOIP plus bridging. This is the most popular method, but it requires public IP everywhere. So if you want to use EOIP, make sure you have public IP everywhere, or maybe you must use the same ISP everywhere. Because the situation in Myanmar is most of the ISP, they are not very happy to give public IP to customer. But in case if you use the same ISP, although it is not public IP, but it is routable. So if you are using MPT everywhere, YTP everywhere, or Ooredoo everywhere, then it is okay, you don't need public IP. But if you are using MPT plus YTP or MPT plus Ooredoo, in this case, you need public IP everywhere. So it is a hard requirement, I would say, for the situation in Myanmar. And it requires static configuration on both hub router and the spoke router for each EOIP tunnel. It means if you have 99 tunnels, you need to do 99 times on the hub, 99 times on the spoke. It is easy to configure because EOIP, normally you just create a tunnel, you just bridge the port, then that's it. It is easy to configure, but it is hard to maintain. Because when you have a lot of manual tunnel, then you need to take a lot of time to monitor it, or maybe when it happens something, you need to troubleshoot it one by one. For PPP plus BCP, BCP stands for Bridge Control Protocol. Actually, in previous presentation, someone mentioned about BCP also, but it was not very detailed about BCP. Here, we will do the example with this BCP technology also. PPP plus BCP, only hub router needs public IP, so it is much more easier. I believe if you just need 1 or 2 public IP, you still can get it. And for the spokes, you can use any ISP, you can use any IP, as long as it can ping to the hub router. For the hub router configuration, it is one-time work. So even if you have 99 locations, then 99 remote locations, then you also need to do the hub configuration only once, only one time. And then whenever you add a new location, you just need to configure a new spoke. You don't need to touch the hub anymore. The hub just stay there. But because it is the client-server type VPN, so it requires more effort on initial configuration. For EOIP, it is easy because just the peer-to-peer tunnel, what is the source IP, what is the destination IP, what is the tunnel ID, then that's it. But for the server client type VPN, then you need to configure the VPN server, the username, password, the profile, the point-to-point IP, something like that. So at the beginning, it is difficult, but after that, it would be easy. Okay, first I will show about EOIP solution. For the headquarter, we have 3 steps to complete. We first need to create the bridge interface, and then after that, we create the EOIP to each branch. As I mentioned at the moment, if you have 99 branches, you need to configure on the hub router to have the tunnels to 99 branches. And then you need to add your LAN interface and the EOIP tunnel into the bridge that you created in the step number 1. Actually, the configuration is very simple. You just go to the bridge, add the bridge, go to the tunnel, add the tunnel. After that, you add the port into the bridge. Then that's it. This is for headquarters. But you need to repeat 99 times if you have 99 remote locations. The branches also 3 steps. Can say it is exactly same as the headquarters. You just need to create a bridge, create the EOIP tunnel back to the headquarters, and then add the EOIP interface and the LAN port into the same bridge that you created in step number 1. So EOIP solution, you need 3 steps at headquarters and 3 steps at branch office. But you need to repeat it every branch. Okay, let's see what are the details in each step. Step number 1, you need to create the VPN bridge. Simply go to the bridge menu, click plus, and then interface name. You can put any interface name. Here I put BRVPN, simply means bridge VPN. And for the protocol mode here, actually if you have only one connection to each branch, then in that case, you don't really need to enable spanning tree. But because now in RouterOS, RSTP is enabled by default, so I think you also don't really need to specifically disable it. In case in the future you might want to add another connection, then you need to go and re-enable it again. So just keep it RSTP. Then step number 2, you need to do the tunnel. Go to interface, add a new EOIP tunnel, local address here. Let me enlarge it. Local address here. It is the public IP of your head office. Remote address, it is the public IP of your branch office. And tunnel ID, it is the number that you agree to use in both locations. So in 2 routers, you need to have the same tunnel ID, otherwise the tunnel will not be up. And previously, I remember some of you might attended my class previously. I mentioned EOIP doesn't have encryption. Yes, but after that, MikroTik added the encryption. So now if you want to do the encryption in EOIP, you can encrypt it by IPsec. You can just simply key in the IPsec password. Make sure your password is identical in both locations. After you key in the password, then the tunnel will be automatically encrypted by IPsec. For another branch, also the same. At the moment, you can see here, I was doing to branch 1. And now I am doing to branch 2. Specifically, only the remote address is different. And the tunnel ID. Other things quite similar. Then next, you need to go to the bridge and go to the port tab. Add all the EOIP tunnels and your LAN interface to the bridge port. This is LAN interface. We assume that we use Ether2 as the LAN interface. So you add Ether2 into the bridge VPN that you created in step number 1 at the moment. And then here you also add EOIP tunnel to the bridge VPN. Another EOIP tunnel to the bridge VPN. So if you have 99 remote offices, you just add 99 times for the EOIP tunnel. Okay, now we finished the head office configuration. You see, quite simple. Branch office can say exactly same, just the IP different. You can see here we also create a bridge VPN, spanning tree mode, RSTP. And then after that, we create a tunnel back to the head office. But here, the only difference is the local address is the public IP of the branch office, and remote address is the public IP of the head office. And this is the number that you agree between 2 offices, and you need to use the same IPsec password for sure. So you just repeat this for all the branches. And then finally, you need to go to the bridge. Go to the port tab, add the port. You need to add Ether2, which is your LAN interface at the branch office, to bridge VPN, and also the EOIP tunnel that go to head office to the same bridge that you created in step number 1. So we have done. For EOIP solution, it is very simple like this. It is simple, but you need to repeat many times according to how many offices you have. The next one, we will talk about PPP plus BCP. In RouterOS, I think in previous presentation also someone mentioned PPP has multiple kinds of protocols that we can use. PPTP, L2TP, and SSTP. Actually, also OpenVPN. PPTP is the most well-known protocol, the most popular one also. The mobile phone can use it, Windows supports it, Linux supports it, Mac supports it, so it is very popular. But because it is very popular, so normally it is easy to be blocked by the ISP or maybe by the authority. In some countries like China, some mobile operators, you cannot use their connection to establish PPTP tunnel for some reasons. For L2TP, it is for layer 2 tunneling. L2TP natively, it doesn't have encryption, but you can combine with IPsec for the encryption. And another one is SSTP. This one is very secure. It is 2048 bits encryption. And it can bypass most of the firewall simply because it uses the port TCP443. This is the HTTPS port. If you don't know what is HTTPS, every day when you open Google, when you open Facebook, when you open YouTube, or some of you listening my presentation live stream, you are using over HTTPS because it is the very important protocol, so most of the firewall will permit it. That's why SSTP is rare to be blocked, but because it is very secure, 2048 bits encryption, so it is very slow. And in case if you are using on the unstable connection like 3G or maybe satellite connection, then in that case the performance will be very, very poor. You will get very high latency because TCP plus very high bit encryption. You guys might say, why TCP? TCP and UDP, the difference is TCP has the process of acknowledgement. When you send something, someone receive it, he will acknowledge back to you. Otherwise, you will resend until he acknowledge. But UDP, no, you just send it. So you can imagine if you are using L2TP, the client, when send a packet to the server, if the packet lost, the client will just continue to send other packets. But for SSTP, if the packet lost, then the client need to resend it again and encrypt it again, so it is slow. And also, it uses more CPU than other VPN protocols, simply because the process of encryption. BCP is the bridge control protocol. It allows sending Ethernet frame over PPP. In this presentation, we talk about layer 2 VPN. Layer 2, currently, I think maybe 99% of networks are using Ethernet. I think will be very few networks still use frame relay or ATM, those kind of legacy technologies. So when we talk about layer 2 VPN, most of the time we are targeting Ethernet over the VPN. BCP is the protocol that allows to send Ethernet frame over PPP tunnel. In this presentation, due to all the PPP tunnels configurations are quite similar. If you used to configure PPTP, L2TP, SSTP, you will realize the configuration really almost 100% identical, just some few configurations different. For example, SSTP, you need to generate the certificate, something like that. For most of the other parts, it is almost the same. So in this presentation, I will talk only L2TP. I will not say PPTP, L2TP, SSTP like that. I will not say one by one. And the reason why I choose L2TP, because at the moment when I talk EOIP, I talk about IPsec encryption. So you guys might want to have another solution with IPsec encryption. So we will talk L2TP plus IPsec encryption. Okay, you can see significantly in the head office here, we have more steps to do. But remember, this is only one time. In head office, we need to create the bridge. We need to add the LAN interface to the bridge. And because we are using VPN, so we need to create the IP pool for the VPN point-to-point IP. And then we need to create the profile, PPP profile, by assigning the bridge in the profile. What is this? This is BCP. Because at the moment I talk about we need to use BCP to send Ethernet frame over the VPN. So how to enable BCP? Unfortunately, in MikroTik, there is no a single click, there is no a button, enable BCP, no. If you want to enable BCP, you need to create the PPP profile and then you select the bridge that you want to use. Then you will enable BCP. And then after that, since it is VPN, server and client type VPN, so you need VPN username and password for authentication. So you need to create Ppp Secret. Finally, you need to enable the VPN server, because here you did a lot of things, but if you don't enable the VPN server, nothing will happen. So you need to enable the VPN server, but here I mentioned we need to enable with multi-link Ppp. Another new thing, what is it? I will explain in the next slide what is multi-link Ppp. So just wait a moment. This is for head office, but remember, although you have 6 steps, but you do only 1 time for head office. For branch offices, you need to do every time you add a new branch. First, you need to create the bridge. After that, you need to add the LAN interface to the bridge. After that, you need to create the PPP profile by assigning the bridge into the profile. This is enabling BCP. And then finally, you create L2TP client interface with multi-link Ppp. Okay, you saw I mentioned multi-link Ppp 2 times. So what is it? Let's take a look. Multi-link Ppp, actually it is the standard defined in RFC 1990. If you would like to read about it, you can go to this link. After the presentation, I will share the slide in MikroTik and also Facebook, so you guys can download it. Multi-link Ppp, it is a method of splitting, recombining, and sequencing data across multiple logical data links. This is the explanation from wiki.mikrotik.com. It sounds like what? It sounds like load balancing, right? You have multiple logical data links, and then you split it, you combine it, and then you resequence it. Yes, it is somehow, for me, I feel it is similar to load balancing over multiple links. In short, in order for layer 2 VPN to work, first you need to send the Ethernet frame over the VPN tunnel, right? So if you cannot send the Ethernet frame through the VPN tunnel, then layer 2 VPN will never work. But how big is the Ethernet frame? Who knows? 1518. This is the number of bytes of the full frame Ethernet, the standard Ethernet frame. So if you want to send this amount of data over the VPN tunnel, it means that you need to have a VPN tunnel that supports bigger MTU than 1518. MTU is maximum transmission unit. It means that the biggest packet size that you can send over the link. But most of the time, most of the VPN tunnels, because of the VPN overhead, most of the VPN tunnels, because of the VPN overhead, the MTU is between 1400 up to 1480. So normally you will not have the VPN tunnel with 1518. So how to do it? That's why we need multi-link. If one VPN tunnel cannot transmit 1518, let's transmit it over 2 VPN tunnels. Then you can get 1518. That's why we need to enable the multi-link Ppp. So when you are sending the Ethernet frame over the Ppp, in case the Ppp doesn't have enough MTU to send over single link, it will establish 2 links, and then you can send over 2 links. And then after another router at another site receives the frame, it will combine 2 fragmented frames together. So you can send 1518 over the VPN. This is multi-link Ppp. Okay, all of these are the definition. Now we will see the configuration. How to do? First, for step number 1 and step number 2, I think they are quite simple. You just create the VPN bridge and then add the LAN port into the bridge. Go to the bridge menu, create the bridge, BR VPN, and then after that go to port and add Ether2, which is the LAN port that we assumed, to the BR VPN. And then step number 3, you go to IP pools, create the IP pool for VPN. This IP pool is for your PPTP client, because now we are on the headquarter router, we are on the server router. When you create a pool like this 10.10.0.1 to 255, it means that whoever connect to this VPN, they will get the IP address in this range automatically. Just like DHCP, they will get one IP from this range. Step number 4, you need to create the PPP profile to enable BCP. You go to PPP menu, go to profile, and then create the profile. And specifically in profile here, you need to mention what point-to-point address you want to use on VPN server. This point-to-point address, it is the IP address that your VPN server use after the VPN is established. You might ask, this address used for what? For pinging. Sometimes you might feel your VPN tunnel is unstable. So how you prove your feeling is true or not true? You need to ping, right? So you need to have point-to-point IP between the server and client for monitoring. So you can monitor the latency, you can monitor the packet loss. And for the remote address, you just select the pool that we created in previous step. Remember, in previous step, we created the pool. Here, we created the pool. So in step number 4, we just put the pool that we have created in the previous step. And in order to enable BCP, here you need to select the bridge VPN in the PPP profile. The bridge that you created in step number 1. Then next, step number 5, you need to create username and password for the client to connect. As I mentioned, this is client-server VPN. So the server needs to have the username and password for authenticating the clients. For username and password, you don't really need to create for every location. I mean, if you have 99 locations, you can simply use one password if you want. But depends on your company password policy. Maybe if your company requires every location must have separate username and password, or you want to set static IP for a specific location, then you need to create separate Ppp Secret. The way of creating Ppp Secret is PPP menu, go to Secret tab, and then create it here. What is the username? What is the password? And what is the service type? And finally, you apply the profile that you created at the moment. Then that's it. Next, how to enable multi-link Ppp. You can enable it on PPP L2TP server. Go to PPP menu, L2TP server here, and then you click on the button, enable L2TP server, and this is the main point, MRRU. MRRU 1600 means you want this tunnel to support 1600. Because at the moment I mentioned Ethernet is 1518. So in order to send Ethernet over the VPN, you must have bigger than 1518. So here you can put any number bigger than 1518. Technically you can put 5000, 10,000, it is okay. But the bigger number is, then potentially you need to establish more VPN tunnels in the backend. Because for the VPN server and clients, if they support multi-link Ppp, let's say if one tunnel can support only 1450 and then you are requesting 1600, then they need to establish 2 tunnels to support this. If you are requesting 3000, maybe they need to establish 3 tunnels to support your requirement. And if you want to use IPsec, then you can apply in here IPsec secret. What is your IPsec password? Because at the moment I mentioned L2TP by default, there is no IPsec, but you can apply IPsec. That's it, we finished for the headquarter. And this work you just need to do one time. Next, we will do at the branch office. Step number 1 and 2, it is the same as head office. Create the bridge, add the LAN port to the bridge. Step number 3, you need to go to PPP profile and create the profile. And this one also similar to the head office. You need to select the bridge to enable BCP here. But you don't need to choose the remote or local address because you are the client. You just connect to the server, then you will get IP automatically. You will not need to assign the static IP here. But in case if you want to have static IP, yes, technically you can do. Step number 4, go to interface menu, create the L2TP tunnel, and then in L2TP tunnel, here it is the main point, MRRU, you need to set 1600. Because at the moment we set MRRU on the server, we told the server, you need to support multi-link. So if the client does not support multi-link, then multi-link will not work. You need to set both sides, server 1600, client 1600. So they both, when they negotiate, they know, okay, both support multi-link, then they can establish multi-link PPP. And here you need to connect to the public IP of the headquarters, username that you created at the moment at headquarters, password that you created, profile that you created for the branch office. And if you want to use IPsec, you just check use IPsec and then key in the password. Then everything will work. For the branch office part, you need to repeat once every time you have a new branch office, but you don't really need to do anything in headquarters. Unless you want to create the separate username password, then you need to go to headquarters router and create the secret. Otherwise, you can use same secret everywhere. Then no matter how many branches you have, you configure headquarters only once. Okay, so that's it for my presentation. Do you have any question? If you cannot think about the question now, you also can send me the question later through Facebook or other contacts on this presentation. Okay, thank you for your attention, and I wish everyone good luck in your lucky draw. Thank you.